Mm. Okay, so hello guys, my name is Sheren Rumengan and I'm from class 3B IBA, and now I'm going to discuss with you about these 7 basic quality tools. So there are 7 basic quality tools which can assist an organization for problem solving and process improvement. And with these 7 basic tools of quality, you can easily manage the quality of your products or process no matter what industry you serve. So here are the tools. So there are 3 categories for these tools. The categories of generating ideas, organize the data, and then identifying problems. So as you can see here, the tools for generating ideas consist of check sheet, scatter diagram, and cause and effect diagram. And the second one, the tools to organize the data consist of Pareto chart and flow chart. And then the last but not least, the tools for identifying problems consist of histogram and statistical process control chart. And now we come to the first one is check sheet. So what actually check sheet is? So check sheets are simple forms with certain formats that can aid the user to record data in a firm systematically. So the data are collected and tabulated on the check sheet to record the frequency of specific events during a data collection period. So as you can see here in the example, a check sheet collects data in the form of check or tally marks that indicate how many times a particular value has occurred. So for the example here, the wrong item in the pick location on Monday it occurs 5 times. In Tuesday it occurs twice. In Wednesday it occurs 4 times, and so on. So it allowing you to quickly zero in on defects or errors within your process or products, defect patterns, and even cause of specific defects. And with its simple setup and easy to read graphics, checksheet make it easy to record preliminary frequency distribution data when measuring out processes. And then the second one is scatter diagram. So the scatter diagram can indicate that there is which one of this following correlation between two variable. The first one here is the positive correlation, so the trend is going up, and the negative correlation, the trend is going down, and then the no correlation is just randomly. So as demonstrate here in the example. And here, as you out of the 7 quality tools, the scatter diagram is most useful in depicting the relationship between two variables, which is ideal for quality assurance professional trying to identify cause and effect relationships. So with dependent values of the diagram's y-axis, here y-axis, and independent values on the x-axis, here. So each dot, these blue dots, each dot represent a common intersection point. So when joined, these dots can highlight the relationship between the two variables. And the stronger the correlation in your diagram, the stronger also the relationship between the variables. And then we come to the third one is cause and effect diagram or a fishbone diagram. So this fishbone diagram helps user to identify the various factors or causes leading to an effect. So usually depicted as a problem to be solved. Named for its resemblance to a fishbone, this quality management tool works by defining a quality-related problem on the right-hand side, right here, of the diagram with individual root causes and subcauses branching off to its left. So this is the causes, subcauses here, and the root causes is this. So you can see here, is the root causes. So a fishbone diagram's causes and subcauses are usually grouped into 6 main groups. So including the measurements, materials, personnel, environment, methods, and machines. So there are 6 of them. 1, 2, 3, 4, 5, 6. So these categories can help you to identify the probable source of your problem while keeping your diagram structure and orderly. So As you can see here on the measurement categories, the cause is lack of tracking for user errors, lack of tracking for user productivity, and then also on the material, the cause is incorrect package product, and on the method, the cause is right here, lack of defining shipping process, and so on. So the effect of these causes is right here. As you can see here, sending incorrect shipment. So this is the example of cause and effect diagram. And then we move to the next one is Pareto chart. So, okay, as a quality control tool, the Pareto chart operates according to the 20, 80, 20, 20, I'm sorry. So, as a quality control tool, the Pareto chart operates according to the 80-20 rule. 80-20 rule. So this rule assumes that in any process, 80% of a process or system's problems are caused by 20 of major factors, often referred to as the fatal few. And the remaining 20 of problems are caused by 80 of minor factors. Okay, so this is the example of Pareto chart. And then we move to the next one is a flow chart. So what is flow chart? So flow chart present a diagrammatic picture that indicates a series of symbols to describe the sequence of steps. As you can see here on example, this is the sequence of steps from the first one until the end, right? So it describes the sequence of steps exist in the operation or process. Right here is the example of the test creation process. And this process consists of the step of sequence. Okay, so on the other hand, a flowchart visualizes a picture including the inputs, activities, decision points, and outputs for using and understanding easily concerning the overall objective through this whole process. So this chart as a problem-solving tool can apply methodically to detect and analyze the areas or points of process may have had potential problem by documenting and explaining an operation or process. So it is very useful to find and improve quality into process. And then the next one is histogram. So I think we all already familiar with this histogram, right? So here is the example. So the histogram can help you represent frequency distribution of data clearly and concisely amongst different groups of a sample. So it allowing you to quickly and easily identify areas of improvement within your processes with a structure similar to a bar graph. Right here, a bar graph. Each bar within a histogram represents a group, while the height here of the bar represent the frequency of data within that group. So here also the example of histogram. This is the manifesting process failures. Right here, the group. There are four group run-up tests, system integration, motor side test, and motor integration. So here are also the frequency. For example, the run-up test, the frequency is around 40. And system integration, the frequency is around maybe 70 or more. And the motor static test, the frequency maybe is around maybe also 70 or more. And this is the has the highest frequency is in the group of motor integration, which is around 120. Okay, so this is the histogram example. And then we move to the last one is control chart. So this quality improvement tool can help quality assurance professionals to determine whether or not a process is stable and predictable, making it easy for you to identify factors that might lead to variations or defects. So the control chart use a central line to depict an average or mean. This is the central line, as well as an upper and lower line to depict upper and lower control limits based on historical data. So here in the example, the upper control limit here and the lower control limit is here, and the mean or average here, and the dot that mark with red color, it means out of control, and that mark with the white color, it means in control. Okay, so by comparing this historical data to data collected from your current process, you can determine whether your current process is controlled or affected by specific variations. So, as I mentioned, this is the red one means out of control, and the white one is in control. So, using a control chart can save your organization time and money by predicting process performance, particularly in terms of what your customer or organization expect in your final products. Okay, so this study identified that it's very essential to apply all these seven quality tools for troubleshooting issues within production processes in the organization. And doubtlessly, all of these aforementioned quality tools should be considered and used by management for identifying and solving quality problems during producing the product and services, and thus the production processes can be affected and improved by multiple factors of these statistical quality tools. Okay, so that's all. We already discussed about the all seven quality tools, and I hope we all can understand with these quality tools. So it can be the tools also for us to improve the quality maybe of for our product, service, or organization later. So thank you for the attention, and bye.